Aluminium and its alloys are among the most important metals in everyday life. They resist the effects of other chemicals, are strong yet flexible, and are light in weight. Aluminium is the third most common element in the Earth's crust. It is extracted from its oxide by electrolysis. This plant is situated close to a deep-water port for importing the raw material. The site is really 3 plants in one. Electrolysis takes place in 4 covered areas, each half a kilometre in length and each containing 78 electrolysis cells. The aluminium is alloyed and cast in the metal finishing shops. Anodes for the process are produced here. Aluminium oxide, often called alumina, is stored here, fed by an underground conveyor belt from the docks. This white powder is alumina. The aluminium is extracted from it. Alumina is imported from Jamaica, Ireland and Spain, where it's been purified from bauxite ore. This is one of the 4 rows of electrolysis cells where the electrolysis takes place. The current is about 157,000 amps at 4.5 volts. This is one of the 312 cells. The electrolysis cell consists of a rectangular steel shell lined with heat-resistant brick and then carbon. Each cell is filled with molten cryolite. The aluminium oxide is dissolved in molten cryolite so that it conducts electricity. 18 carbon anodes dip into the electrolyte. During the electrolysis, aluminium ions move to the cathode, gain electrons and become aluminium metal. Oxide ions move to the anode, where each ion loses 2 electrons and the atoms pair up to become oxygen molecules. These are the chemical equations. As the electrolysis proceeds, the aluminium oxide is decomposed into aluminium and oxygen. A crust forms on the electrolyte, and this has to be broken to feed in new aluminium oxide. This happens every 3 to 4 minutes. The hoppers on the cells are filled from an overhead ore bucket every 16 hours. The electrolyte is at about 955 degrees Celsius. At this temperature, the carbon anodes gradually burn away in the oxygen from the electrolysis. Eventually, the anodes have to be replaced, and this happens every 28 days or so. The remaining carbon is broken off the old anodes, crushed, mixed with new coke and pitch, and pressed into shape. The newly pressed anodes are baked for about 24 hours in gas-heated pits. Steel stubs are fitted onto the baked anodes. The anodes are sprayed with molten aluminium to protect the top and sides. Electrolysis takes place 24 hours a day, 365 days a year. A loss of power of more than a couple of hours would be disastrous, as the electrolyte and the aluminium would solidify. Liquid aluminium is sucked from the cell into a brick-lined steel crucible. Each cell produces about 50 kilograms of aluminium per hour. Some of the aluminium is cast as almost pure metal. Some is made into alloys by adding other metals. This metal being added is magnesium. Aluminium alloys, or pure metal, can be cast into different shapes. The liquid metals are poured into moulds where they solidify and can be lifted out.